For countless generations, humanity has looked up at the stars with wonder, longing, and curiosity. The vast night sky has inspired myths, guided explorers, and sparked scientific inquiry. At the heart of this curiosity lies one enduring question: are we alone in the universe? For most of human history, that question remained purely philosophical, driven by imagination rather than evidence. But with the advent of advanced scientific tools and technologies, we are now closer than ever to finding a meaningful answer. A major leap in this journey has come with the development of the James Webb Space Telescope, the most powerful space observatory ever constructed. Designed to look deeper into the universe than any of its predecessors, it can detect the faintest signals of light and heat from the farthest and most obscure corners of the cosmos. This capability opens up new possibilities for observing distant planets known as exoplanets that may harbor the conditions necessary for life. Among these, one planet has stood out as especially intriguing. Proxima b Proxima b is an exoplanet orbiting the red dwarf star Proxima Centauri, which happens to be the closest star to our own solar system. At a distance of just 4.24 light years, Proxima b is, in cosmic terms, a near neighbor. It is believed to be a rocky planet, roughly 1.7 times the size of Earth, which places it within the range of Earth-like planets in terms of mass and composition. Its position within the so-called habitable zone, the region around a star where liquid water could potentially exist on a planet's surface, makes it a particularly compelling candidate in the search for life. What has further elevated interest in Proxima b is a combination of observational data and tantalizing mysteries. Recent findings using the James Webb Space Telescope have revealed something unexpected: patterns of light appearing to come from the dark side of the planet, the side that remains in perpetual night due to its tidally locked orbit. This phenomenon is particularly significant because, on Earth, similar patterns of illumination seen from space are generated by artificial city lights. The idea that such lights might be observed on a distant planet suggests, at least hypothetically, the existence of an advanced civilization capable of artificial illumination. Tidal locking means that one hemisphere of Proxima b is always facing its star, bathed in constant daylight, while the other side is forever cloaked in darkness. This type of orbital behavior might seem hostile to life as we know it, but scientists believe that the twilight region between the two hemispheres, the so-called terminator zone, might offer conditions stable enough for life to develop, especially if the planet possesses an atmosphere capable of distributing heat. The presence of water in this region is considered a real possibility, and where there is water, the potential for life significantly increases. Adding even more intrigue was the detection of a strange and unexplained radio signal in 2020. This signal, picked up by a radio telescope in Australia, appeared to be coming from the direction of Proxima Centauri. It lasted for nearly 30 hours before fading into silence. Notably, every time the telescope was aimed away from the source, the signal disappeared entirely, suggesting that the origin was highly specific and not a general background event. While many experts urge caution, noting that natural phenomena or Earth-based interference could explain the signal, others see it as a possible indicator of technological activity, perhaps even a deliberate transmission. Despite these exciting clues, we are still far from being able to visit Proxima b. The vast distances between stars make human travel currently impractical with existing technology. However, scientists and engineers are actively exploring new methods of deep space travel. One of the most ambitious efforts is known as the Breakthrough Starshot Initiative. This project aims to develop ultralight spacecraft known as nanocraft, which would be powered by focused laser beams from Earth. These craft, traveling at up to 20% the speed of light, could potentially reach Proxima b in just over 20 years, though sending and receiving information back would take several additional years. If successful, this would mark a groundbreaking step in interstellar exploration, bringing us closer to the possibility of physically observing and studying an alien world. It is important to understand that Proxima b is not the only world that holds promise. thousands of other exoplanets have already been discovered, many of them located within their stars' habitable zones. Some particularly notable examples include Kepler-4 and Kepler-186f planets orbiting stars that share similarities with our own Sun. These worlds may also possess the right conditions for life, though they are much farther away than Proxima b, and thus more difficult to study in detail. Still, the growing list of Earth-like planets reinforces the idea that life may not be unique to our planet. Astronomers estimate that approximately 22% of the stars in the Milky Way galaxy are similar in size and temperature to our Sun, with hundreds of billions of stars in the galaxy. This means there could be tens of billions of Earth-sized planets orbiting Sun-like stars. Even if only a small fraction of these worlds harbor life, the implications are profound. The universe may be teeming with biological diversity. From simple microbial life to complex, intelligent civilizations, the James Webb Space Telescope is revolutionizing our understanding of these distant worlds. Its ability to analyze the atmospheres of exoplanets through infrared spectroscopy allows scientists to search for the chemical signatures of life, such as oxygen, methane, or water vapor. These tools offer the best chance we have of detecting life without needing to physically visit these planets. Each discovery made by the James Webb and other observatories pushes the boundaries of what we know and reshapes our understanding of the cosmos. The possibility that we might soon detect definitive signs of alien life is no longer confined to science fiction. It is a legitimate scientific pursuit, one that continues to inspire new generations of researchers, dreamers, and explorers. Whether Proxima b turns out to be the home of a technologically advanced civilization, a planet with microbial life, or a world entirely lifeless, it represents a turning point in our search for meaning beyond Earth. It forces us to confront not only the question of whether we are alone, but also what it would mean if we are not. Would contact with another intelligent species change our understanding of ourselves? Our religions, philosophies, and politics? Would it unite humanity or divide it further? As we peer deeper into the universe, one thing becomes increasingly clear: the cosmos is not a silent, empty void. It is dynamic, mysterious, and filled with potential. Proxima b may very well be the first in a long line of discoveries that bring us face to face with life beyond our solar system. Or perhaps, as we continue exploring, we will find something even more extraordinary, something we have yet to imagine. Until then, we remain explorers, guided by curiosity, driven by science, and filled with wonder. The stars still call to us. And with each new telescope, each mission, and each breakthrough, we answer with determination. The journey to understand our place in the universe has only just begun.